There are a few methods that you can use to establish breaklines in a surface. Breaklines instruct Civil 3D of points that have a linear relationship with each other, and 2 or more points are required to define a breakline. Let's examine how to create breaklines that can be added to a surface for proper triangulation. Along with creating regular polylines, you can actually use 3D polylines as well. Let's minimize the points that we see by using a pre-existing point group called for breakline creation. We'll go ahead and right-click on that, choose Properties. This point group can be used to match specific descriptions and so on to actually minimize the amount of points that you see in your drawing. We'll go ahead and go to the Include tab, toggle on with raw descriptions matching, and we'll go ahead and type in ditch, asterisk, comma, BKL, asterisk, comma, WDL. If you want to look at the point list, you can see the points that are being displayed. Go ahead and click OK. Now, using point group display functionality, we'll right-click on here and choose Properties, and we'll go ahead and put No Display up top, and then 4 breaklines above that one. Click OK, and you might need to do a regen. And now the only points that we see are the points that we're interested in creating breaklines for. So the first one we want to do, we have these points with a raw description of BKL. We just want to connect them to make a eventual breakline into a surface. Set the current layer to BK_breakline, and we'll go ahead and start the regular polyline command. Now there are a couple of really cool options for transparent commands that we mentioned before. If you want to be able to actually select point objects, the transparent command 'PO will allow you to do so. I'll type that in, and now all you have to do is simply pick anywhere in the graphic, and it'll automatically connect the dots for you. Press Escape to get you back into the polyline command, press Escape again to get out of the command. So here are all the ditch points that we want to connect the dots with, and we'll just simply do a 2D polyline. You'll learn later on that even though the polyline will be 2D, it'll actually snap itself to the points of the surface to automate the breakline creation at those elevations. We'll click on the layer dropdown, and I'll go ahead and set my current layer to BK_flowline. Let's go ahead and start the polyline command. We'll use the transparent command 'PN because what this will allow us to do is connect the dots if we know the point numbers, and you can use dashes and commas. We'll do 791 dash 797, comma 799 dash 804. And watch what happens in the drawing. It'll automatically connect the dots for us. Press Escape once to get you out of the command, and press Escape again to cancel the command completely. Now, let's go ahead and add a 3D polyline of a head wall for proper triangulation within the surface. So the first thing we want to do is I need to get back all the points. So I'll go ahead and right-click on the point groups, go to Properties, and we'll just put the All Points point group at the top of the list, click OK, and do a possible regen, and there's my points. So what I want to do is start the 3D polyline command. To do so, simply type in 3D poly and press Enter. Now with this one, as long as I have node snap turned on, which I do, I can simply snap to the different points that I need to. We want to snap to point 701, so I'll go ahead and node snap there, because this will grab the elevations automatically. We'll go ahead and snap to 798, and lastly, we'll go ahead and snap to 708. And that is my 3D polyline snap at those elevations. Adding survey data to your surface is simply a matter of adding the breaklines and points that were generated by the survey database and adding them to the surface. First, let's go ahead and create a surface. In the Prospector tab, Surfaces category, right-click, and choose Create Surface. We'll give this a name of EG. We'll go with the default 1'5" background, and make sure that we have Tin Surface selected. Click OK. We now have a new entry for our EG surface. It's empty, and we're going to add the survey data. Let's navigate to the Survey tab, and even though our drawing is completely empty, let's watch how we can actually do this. Let's go ahead and open up the completed Infinite Skills survey database, open for edit, and we'll right-click on the Figures collection and choose Create Breaklines. Notice how we have EG selected already. You can, of course, select different surfaces here. You can even create new surfaces right off the bat here. Based upon the figure prefix definition, breakline is checked on or off. So these are definite breaklines, and of course you can scroll through here and see if there are any additional ones that you may or may not want to add to the surface. For instance, maybe we don't want this stone wall because they located the top of the stone wall. We'll toggle those 3 off and go ahead and click OK. This automatically adds figures to the drawing, and of course these figures are linked to the survey database. We'll go ahead and type a description of from survey database, and these are standard types, which are actually 3D geometric lines. There are options to weed them, meaning take out vertices if you have too many vertices, and supplementing, where you can actually add distances if your distance between vertices is too short. We'll go ahead and click OK here, and now our surface has those breaklines in them. we of course are not completely finished, as we need to add the points to the surface as well. You can't right-click and add those to the surface automatically. You actually have to bring them in as Civil 3D Cocoa points. We'll simply drag the survey points in here, and now we have all those survey points as Cocoa points locked to the survey database inside our DWG file. If we navigate to the Prospector tab, let's peruse the point groups category for a second. Let's go ahead and right-click on point groups and choose Update. Now all the point groups contain the points that they should based upon their criteria. And we already have a points-EG predefined. Right-click on points-EG and go to Properties. And if we navigate to the Include tab, you'll notice that we basically toggled on through the raw description matching which points should actually be brought in as points. We'll go ahead and click OK here. And now let's add that point group to our surface. Expand EG, expand definition, and go ahead and right-click on point groups and choose Add. Now let's go ahead and select points-EG and simply click OK, and notice how the surface is triangulated and we are ready to go. Now let's say we want this surface to rebuild automatic every time we actually add data or modify data. So let's go ahead and right-click on EG and choose Rebuild Automatic. Let's go ahead and select the surface, and in the General Tools panel, select Object Viewer. The Object Viewer is a great way to minimize the viewing of 3D data in a viewer, making it much easier to view the data in 3D. You have different visual styles that you can choose from, whether it's wireframe, or shaded, or realistic, which will actually show materials. But it's a nice way to actually just be able to view your data and just rotate it in 3D. Press Escape to get out of the Object Viewer, and Escape again to clear your selection set. Proximity breaklines are 2D polylines that initially have an elevation of 0. Each point on the polyline, the northing, easting, is calculated based on the closest surface point when you bring it into the surface. First, let's just verify that we have Rebuild Automatic turned on by right-clicking on the surface and choosing Rebuild Automatic. Now let's go ahead and zoom in to the bottom right part of our surface, and let's go ahead and bring in this breakline that is a polyline. If I hover over this, you'll see it's just a polyline. We'll expand EG, expand definition, right-click on breakline and choose Add. We'll call this one Miscellaneous Breakline, change our type to Proximity, and we'll just go ahead and click OK. When prompted to select the objects, go ahead and pick this object here, press Enter, and notice how the tin updates automatically. Let's look at this other polyline that we have here, this ditch bottom that we created before. We'll go ahead and right-click on Breaklines and choose Add, and we'll call this one Ditch Bottom, change our type to Proximity, click OK, select the object, and press Enter. Our surface updates, but let's go ahead and view it in the Object Viewer to verify everything. Select the surface, General Tools panel, and then Object Viewer. As you change the different visual styles, you can actually see your surface updating automatically. Press Escape to get out of the Object Viewer. Now let's talk about standard breaklines. So standard breaklines are actually 3D lines. In other words, items like 3D polylines, feature lines, or figures. The X, Y, and Z coordinates of each vertex are used in the surface. Let's go ahead and look at an example of this. We'll go ahead and right-click on the breaklines category and choose Add, and we'll call this one Detention Pond. Leave it set to standard. We can use weeding factors to take out vertices. This would be useful if, let's say, you were bringing in some sort of polyline that had too many vertices, or we can actually add vertices. So for instance, these lines here only have vertices at the PCs and over here at the endpoints. If you want to tighten up your triangulation, you could increase what's called the supplementing factors, and that would increase your triangulation. We'll go ahead and click OK here, and we'll do a crossing window of those two objects, press Enter, and now our surface updates automatically. If you'd like to see the surface update, and this will be a kind of a standard procedure as you're adding data to the surface, you'll add it, rebuild it, then take it into the Object Viewer to make sure that your triangulation is doing exactly what it's supposed to do. Headwall breaklines are very useful when you only have either the top or bottom, northing, easting elevation of a feature, and either a consistent elevational difference between the points, or you've actually measured the distance at each vertex when you were in the field locating the objects. This depth would, in most cases, come from the surveyor's notes, of course. A few examples of using a headwall type breakline are curbing, consistent depth for all points, or a concrete culvert where the top of the culvert was located and the depth to the bottom points will be measured in the field. So let's go and look at our headwall right here. I'll go ahead and select it first. This headwall is a 3D polyline. The surveyors tape down to the bottom depths at each location. So instead of them actually having to locate the bottom of the headwall, we can simply add this as a headwall breakline and we'll be good to go. Let's go ahead and expand surfaces, e.g., definition, right-click on breakline and choose Add. So this is a concrete culvert, so we'll give it that description. You don't have to, but it will help you when you have to go back to the surface and you want to review what data you added to it. Pick on the type dropdown, and we'll go ahead and pick on wall. We'll go ahead and click OK. Now, because this object is already selected, it'll just immediately prompt us for the offset side. So as you can imagine, Civil 3D needs to know the side where the wall should be. You can simply just click on that side. Now, notice what it's asking us to do. Enter option for wall heights, all or individual. So if they were all the same, like let's say curb and gutter, then you could just say all, -0.5, you'd be done. But each of these is different, so we'll go ahead and pick individual. Now, again, look at the command line window, and notice the drawing is actually saying, okay, I'm at this point now. What do you want to do for the elevation for offset point? So right now, if I were to type in the value that they taped down, it would actually go to that elevation. So make sure you're looking at the command line window when you're ready to enter this data. There's an option for delta, change in. So we'll go ahead and click on that. And now we need to actually define the depth. In this case, it's 5. Now watch what happens when I press enter. It goes right to the next vertice. Now, when you zoom in, it will clear that graphic. So just be aware of that. The depth here is -1. Press enter. Notice the X is right here. The depth here is -0.4. Press enter. And our surface immediately updates with the triangulation because we have Rebuild Automatic turned on. We'll go ahead and select it. Object Viewer. We'll change our visual style to, let's say, conceptual. And now you see our head wall is automatically created for us. Civil 3D has the ability to use contour data to create a surface. Contour data can come from a variety of sources, for instance, USGS, aerial, etc. Let's say for our example here, we have a bathymetric survey that we got back from the surveyors, and it's contour data. The first thing we're going to do is isolate the layer isolate command, pick one of the objects, press enter, and now we have that layer isolated. We're going to create a separate surface. We'll eventually use the paste command to paste them together in a future video. We'll go ahead and right-click on surfaces and choose Create Surface. We'll call this one Surveyed Lake. We'll go with the defaults for style and render material, and we'll click OK. So make sure you expand the Surveyed Lake surface, and in the definition category, we have contours. Let's go ahead and right-click on there and choose Add. Let's go ahead and give this a name. We'll call this one Bathymetric Survey. Weeding will reduce the number of points that will be generated along a contour, as contour data sometimes contains more vertices than is necessary. The supplementing factor section will add vertices along contours if they don't have enough. Note, the weeding factor distance must be less than the supplementing factor's distance. This area here allows you to eliminate triangles where 3 points are at the same elevation and the edges that connect the points on different data contours are at that same elevation as well. This will reduce the number of flat areas and create a more realistic surface. We'll go ahead and click OK. And now we'll go ahead and select our contours. However, there is a boundary here that we do not want. Using standard AutoCAD functionality, hold the Shift key down and click on that object, and it becomes unselected. Right-click or enter, and now we have our data inside that surface. Now it looks like nothing's there, but let's go ahead and unisolate our layers, turn all our layers on, and there is our surface. Notice how it matches the contours almost exactly, which is really, really nice. These polylines are truly dynamic, so if we go ahead and right-click on our surface and choose Rebuild Automatic, and we go ahead and select one of our polylines, and we move it, you will notice that the contours update automatically. Civil 3D allows you to add boundaries to a surface. The types of boundaries that you can add are outer, show, hide, and data clip. An outer boundary is used to bound the entire surface. However, the surface data outside the boundary is still technically in the drawing and can be displayed if you adjust the outer boundary. A hide boundary is used to hide an area that you do not want to triangulate or show triangulation for. An example of this would be a pond, a building, and so on. A show boundary is used to show the inside of that hide boundary. An example would be, let's say you were designing an island in the middle of a lake or a pond, and you could actually show the outside where the land is, hide some of the pond, and then show the actual island. Lastly, a data clip boundary removes the surface data outside the boundary from the drawing, not allowing it to be inside the drawing, making your drawing a little smaller. So let's go ahead and look at a couple of examples here. Let's first look at a building. So we've got a building right here, and we obviously don't need to show triangles inside there. So let's create a hide boundary of this building. First, navigate to the surface definition. We'll expand surfaces, expand EG, definition, and here are our boundaries. As with everything, simply right-click on the category and choose Add. We'll call this one BLDG. This will be a hide boundary. Notice how you can pick the ones here. And for this example, you do want to have on non-destructive breakline. What this toggle does is it allows you to tell Civil 3D to triangulate right up to the actual object, even if surface data is not there. If you toggle it off, it'll only use surface data to actually create the boundary. We'll go ahead and click OK and select our building, press Enter. There's our hide boundary. Let's look at another example here. Let's just do a zoom extents. Let's actually use this 2D polyline as an exterior boundary for our entire surface. We'll go ahead and right click on boundaries and choose add. Call this one EXT. And for this one, we'll make sure we set this to outer boundary. Toggle off non-destructive breaklines because if we don't have any data to the 2D polyline, we don't want to necessarily just stretch those triangles because that will obviously be erroneous data. We'll go ahead and click OK here. We'll pick the 2D polyline. And notice how it just goes to the data that's actually inside that surface. So these are contour lines or points that Civil 3D is triangulating to. Surface properties allow you to change many of the settings and order of surface operations. To navigate to your surface properties, simply select your surface, and in the contextual ribbon Modify panel, choose Surface Properties. The Information tab is pretty simple. You can simply change the style and render material for this surface, as well as the name. Let's say we'll change it to Contours and Triangles just for the heck of it. Click Apply, and as you can see, it's changing it automatically. In the Definition tab, however, there are many build and data and edit operations that you can change, as well as the order and surface definitions. As we look over here, this is one of the things that makes Civil 3D surfaces much superior to other surfaces. They actually store every data entry that you've ever done to the surface. What you can also do is toggle any one of them off to see if it's something you want to get rid of. Let's say you want to get rid of this exterior boundary. Click Apply, rebuild the surface, and as you can see, we're done. If you want to completely remove a specific data operation, simply right-click on it and remove it, and it will be removed forever, so be careful with that one. What's also nice is that you can change the priority of these operations. This is very useful, especially if you're not getting the triangulation you think you should be getting. If it's triangulating incorrectly, just try changing the order around and I guarantee it'll fix it. Let's look at the build operations. You can tell Civil 3D what to do with elevations. So for instance, if I want nothing below 0, I would say, hey, put nothing below 0 in there, as well as don't allow anything above a certain value. So if you know your maximum elevation in your surface should be around, let's say 300, maybe you type in 500. And that way any bogus elevations that may have a 999 value and so on, it will not be in the surface. If we scroll down, there's also the opportunity to change the angle. So if you have very tiny slivers, you can say, hey, don't let it exceed this angle, as well as the maximum triangle length. So I can say, let's get rid of any extra triangles that have a distance greater than 150. Click Apply, Rebuild, and you'll notice how it gets rid of all those extra triangles. Now be careful with this, because if you do have a point that was surveyed maybe that's greater than 150 and you want to keep it, it will of course get rid of it. There are additional settings and data operations as well here that you can edit. The Analysis tab is where you would do your analysis. So things like slopes, elevation banding, slope banding, etc. You define the analysis and bands in here. Lastly, the Statistics tab is a great location to see what your maximum elevation is, your minimum coordinates, the number of points, maximum triangle area. If you want to copy this out into, let's say, a text file or even AutoCAD, just simply right-click, copy to clipboard, and then paste it using Control-V, and there is our actual data from the Statistics tab. Most surface edits are done by selecting the surface and choosing the appropriate surface edit from the contextual ribbon. Before performing edits, some surface edits require that the style display the triangle and points of the surface. So let's go ahead and create one. Let's navigate to the Settings tab, Surface Category, Surface Styles. Let's go ahead and start with this one called Contours and Triangles, and we'll make one called Tin Editing. Right-click on it and choose Copy. We'll start in the Information tab, and we'll call this one TIN Editing. Let's just go to the Display tab, because all we care about is displaying the triangles and points. So first we'll select everything here and turn everything off. Click in space here again, and we'll just toggle on triangles and points. If you want to change this for the model view as well, you could do the same thing. Let's go back to the plan view. Now we really want these to stand out. So I want my points to be on a color of yellow, and I want my triangles to be a color of red. Click OK, and now that's how they'll be displayed. Even though they're set to a layer, we're overriding the by-layer property. Now let's navigate to the Points tab for a second, because this is how you define what the points should look like. So if you want an X, a plus sign, etc., simply click over here and you can tell Civil 3D what you want those to be. Go ahead and just click the plus sign. That's good enough for us. I do not recommend you have it scale automatically. Just pick some default size in absolute units and just go with that. Click OK. Now let's change our surface to use that style. Very quickly, we can just do this by clicking on the surface, navigate to the Properties palette, and choose that new style that we just created. And there is our new surface style being used by this surface. So in this section, we want to talk about how to delete lines and what they refer to as lines, meaning triangles. So you're always going to have erroneous triangles, like let's say this section here and this section here. So let's look at how you can actually remove those. We'll go ahead and select the surface. And in the Modify panel, we have the Edit Surface dropdown. Let's simply click Delete Line. A quick way to do this is to simply do a crossing window like so. Make sure you get the right triangles and then press Enter. It deletes them and you can keep going. You can also use the fence option. So type F and then Enter, and that also will allow you to select triangles and get rid of them. We'll just keep going. Last section here, select those, press Enter, and now we're done. Once you're done with your command, press Escape and Escape again. The beauty of all this editing functionality is that they actually will live in the surface. So you don't have to worry about undoing or exiting the file. Those surface edits are all stored in the Surface Properties Definition tab. So we can toggle them on as we need to, remove them, and so on. Most surface edits are done by selecting the surface and choosing the appropriate surface edit from the contextual ribbon. We'll look at editing, removing, and adding surface points. Let's go ahead and zoom into the bottom right part of our surface. Now let's say if we had contours displaying and they weren't displaying kind of exactly the way they should be, just because they didn't get enough points in this area, you could actually add surface points. Let's go ahead and select the surface, and we'll go ahead and pick on Edit Surface, and here are all the different point options. Remember, whatever point edits we make or additions, do not change or edit the Civil 3D Cocoa points in any way, shape, or form. They will still be the Civil 3D Cocoa points that they were, whether or not they came from a survey database or were created in the drawing, and you are not making edits to those actual points. These are surface points. So let's go ahead and click on Add Point, and let's go ahead and just verify. I'll right click on my O-snaps and let's turn midpoint. I just want to add some points to, let's say, the midpoint to just kind of get some extra points for better triangulation. We'll go ahead and click on here. Notice the command line window. It says new elevation point 103.17075. This is the exact location where I snapped, so it actually does grab the elevation. So if you have 3D points and you want to add just, let's say, the points to your drawing, you could just do it that way as well. I'll press Enter. Notice how the triangulation goes right to that point there. Let's go ahead and do the same thing over here. Same elevation, we'll press Enter, and as you can see, that's how you add surface points. Let's go ahead and look at an existing point. The surveyors come back and say, you know, actually this point here at 788, there was a bogus elevation in some sort of way through the data collector or whatever it is, and we actually need to edit the point. This point, however, the Civil 3D Cocoa point, is stored in the survey database, so we can't really edit it unless we have permissions to. Press Escape here. We can edit the surface point with the correct elevation. So we'll go ahead and click on Edit Surface, Modify Point, and this is why you need the surface points displayed with a style so that you can actually select them. Press Enter. It does tell you the elevation, and let's say the true elevation is 102.98. So we'll type in 102.98, press Enter, and although it looks like nothing happened, I'll press Escape here. If we hover over this, you'll notice that the elevation is right on there, okay? But again, notice how it did not edit the Civil 3D Cocoa point. Let's say we want to remove some points. I still want to maybe keep a survey point, but I want to remove it from the surface because it no longer is necessary. We'll go ahead and click on the Edit Surface dropdown, and we'll go ahead and click on Delete Point. And now you're picking the actual surface point. Press Enter. Notice how that gets deleted immediately. So those are some quick and easy ways to make surface edits using points. Navigate to the surface properties, and with any kind of surface edits, they're all stored in the actual surface here. We could remove entries, we could just toggle them off with Civil 3D surfaces. Let's look at the Paste Surface command, which allows you to paste multiple surfaces into one surface. First, let's look at the Prospector tab to see what we have in our drawing. We have 3 existing surfaces that we want to combine in one, thereby allowing us to have one combined EG that we can use later on in the project. We'll first create a surface by navigating to the Create Ground Data panel, Surfaces dropdown, click Create Surfaces. We'll call this surface Combined EG, and we'll leave it with the style Contours 1 and 5-foot background. Click OK, and here's our surface. Now normally, you would select the surface in the drawing and then choose from the contextual ribbon to paste the surface. However, we have no data in the combined EG surface, so we'll navigate to the edit operation through the combined surface itself. Make sure you expand combined EG, expand definition, right-click on edits and choose paste surface. When pasting surfaces, it does actually matter the order in which you paste them. Typically what you do is you paste in the larger or the outside type surfaces, and then any surfaces that are inside or overlapping, you paste in afterwards. Note you can always change the order in which the surface will triangulate in the Surface Properties dialog box. We'll go ahead and start with the EG surface, as this is the larger one. Go ahead and click OK, and there's the EG surface in our combined EG. We'll go ahead and right-click on Edits again and choose Paste Surface. And this time we'll add in the detention pond. Click OK, and now we have the detention pond in our surface. Lastly, right-click, choose Paste Surface, and we'll go ahead and click on the Lake Survey Contours surface. Click OK, and now we have that surface in the combined EG as well. Select it once, the surface is one entity. The great thing, of course, with this workflow is that any changes made to any of the individual surfaces will, of course, automatically update you, telling you the surface is out of date, and you can always set your surface to Rebuild Automatic to have it update automatically. Don't forget, if you do need to remove a surface definition, you can always remove it from here in the Prospector tab by right-clicking and selecting Delete, or you can navigate to the Surface Properties and remove it in the Definition tab. Let's look at some additional surface edit tools that are available. Let's go ahead and select our surface, and let's navigate to the Surface Tools panel. You'll notice here a tool called Extract Objects. This is a very useful tool if, let's say, you need to extract information from a surface and then bring it into, let's say, another civil engineering software, or you want to just extract borders or contours from a surface and then put it into another surface. We don't need the border here, so we'll toggle this off. But let's go ahead and click on Select All here, because I want to select specific major and minor contours from the drawing by clicking this button here. I'll go ahead and select them in my file, and then right-click. We'll do the same thing for the minor contours, so the minor contours get selected. We'll go ahead and click OK, and those objects are now extracted from the surface and now have 2D polylines with an elevation. So if we look over here in my Properties palette, this is the contour at an elevation of 83. Go ahead and select our surface again. Let's look at some additional tools. If you look at the tools option here, there are many additional tools that make it easy to do different kinds of functionality related to a surface. For instance, I want to, let's say, move some blocks to a surface and have them drape right to it. We'll click on Move Blocks to Surface, and we'll go ahead and select these 3 blocks in our drawing. Click OK, and let's see what it actually did. Let me press Escape here to clear my selection set. Now, if you look here, I've got some tree blocks, and I even have a transmission tower block here. Turns out these are actually something called Multiview blocks. A Multiview block can basically be displayed in multiple views differently. In other words, in 2D, which is like the top view here, it looks a certain way. But when you rotate the view in 3D, you will actually get a 3D representation of that actual block. There are many standard Multiview blocks that come with Civil 3D, and if you navigate to your tool palette, and then right-click on the header here, you'll notice there's a category called Civil Multiview Blocks. I'll go ahead and select my Multiview blocks here, and we'll go ahead and select the surface, and let's see what it actually did. Let's navigate to the Object Viewer, and if we rotate our view, and we'll zoom into that location where those blocks are, you'll see here, these blocks look fantastic in 3D. I've got a nice transmission tower there, I've got some trees here. Very useful if you want to do visualization. One of the other really cool tools is the ability to raise or lower your surface. Let's go ahead and select my surface. We'll go to Edit Surface and then choose the Raise Lower Surface command. Let's say you have a proposed surface, but you want to start grading or doing some sort of design a certain distance below the elevation that you're supposed to start design at. So I'll just type in -0.75 and press Enter, and now that surface is lowered by that distance. One of the other great things about doing a lot of these surface edits, if you want to get rid of it or turn it off, select the surface and then choose Surface Properties. Again, navigate to the Surface Definition tab. You can simply toggle these off or right-click and remove them, and then your surface will be rebuilt, going back to the way it was before. Civil 3D has tools that allow you to see any kind of surface analysis that may be necessary during your design process. Some examples of surface analysis are elevation banding, slope arrow banding, and so on. Let's examine the workflow for displaying surface analyses. Let's first look at the settings and styles necessary to define. If we navigate to the Settings tab, Surface Category, and we'll expand Surface Styles. Let's look at a slope banding style already in the drawing. We'll double-click it. So the Analysis tab is where you define how you want your analysis to be displayed in the drawing. You have directions, elevations, slopes, and slope arrows. If we expand slopes, you'll notice here initially a scheme called Rainbow will apply to the slope banding. It'll do a quantile type grouping, but you can define it by equal interval, standard deviation. You can also define the number of ranges and the precision, as well as what type should be displayed for the type of banding that you're doing. The Display tab, of course, will tell Civil 3D in the different views what you want to display. So as you can see here, we have slopes turned on for plan, and if you want that to be applied to the model view, you could do so as well by simply toggling on the model view. We'll click OK. Let's go ahead and apply that style to this surface and see what happens. Go ahead and select your surface, navigate to the Properties palette, and let's go ahead and change our style to Slope Banding 2D. As you can see, it automatically applies that slope banding, but we're not completed yet. What we want to do is define the actual bands that should be applied for better design analysis. We'll click on Surface Properties, and let's navigate to the Analysis tab. Change your type to Slopes. Notice how it's just doing 8 by default. We only want, let's say, 3 because we have different ranges of where we can build based upon the slope in the surface. Click the Run Analysis button there, and now we have 3 bands. We can then go in here and define our actual band that we want to be defined. So we'll just do 0 to 5 for the first band, 5 to 10 for the next, and then anything above 10% we cannot build on, so we'll just leave it set to the maximum slope that's defined already. So let's say we want to change our color. We can click over here where the red is. We just want to make it yellow here because it's important to actually just see the places we cannot actually build on with red. So we'll click on that and choose red, click OK, and then apply, and you'll notice that these are the locations of where we have slopes exceeding that 10% or above range. If you wanted a table of some sort to actually show or display the areas, you could click on Add Legend right there. We want a slopes table. Of course, you want it to be dynamic. Click in the drawing, and there's our table dynamically linked to the surface, so if you change anything, the table will update automatically. Let's say we want to see how this surface drains. Let's go ahead and create a new one. We'll go ahead and start with our tin editing one. Right-click on there and choose Copy. Let's go to the Information tab and call this one Tin and Slope Arrows. We'll go to the Analysis tab. Let's change the default slope arrows to not show some sort of rainbow color. We just want to see it with one color, let's say blues. We'll go ahead and click Display tab, and we'll go ahead and select all these here, toggle them off, click the slope arrows, just that on, and we'll go ahead and toggle on the triangles as well. Click OK, and now let's go ahead and change our surface to that style, and you'll see here, it automatically shows you the way the surface is draining. Civil 3D provides dynamic labeling functionality. What this means is that any labels you add to Civil 3D that are associated with a Civil 3D object will update automatically. Let's look at this functionality as it relates to surfaces. If you wanted to start labeling functionality, it is available in the Annotate tab, Labels and Tables panel. However, it's a little easier if you select the surface you want to label, and then in the Labels and Tables panel, you choose it from here. Note that if you pick the Add Labels dropdown, the default commands are listed here. However, if you select the command right here, instead of choosing Add Surface Labels, it will use the default style defined by the command settings, not allowing you to change what labels get used. It's recommended you choose the Add Surface Labels option instead. Let's look at the different label types: slope labels, spot elevation labels, and contour labels. These are the styles as per the category that we have selected, and we'll just pick on %. Go ahead and click Add, and notice how you have 2 types of labels. You can have 1-point or 2-point slope labels. Let's just choose 1-point for a second and see what happens. When you choose 1-point labels, what Civil 3D does is it drapes the label onto the triangle face and shows the exact slope as it is on that triangle face. Press Escape, and let's go ahead and choose Slope Label again, and click Add. Pick our surface, and let's choose 2-point. Now with the 2-point label, what it does instead is it takes the actual points and where they fall on the surface and defines the labels from those 2 points, ignoring what's going on in between. Press Escape, and what's great about these labels, they will dynamically update when you grip edit them, or if you simply move them around the surface. You can also copy them. So if I use the standard AutoCAD copy command and copy them around the surface, you'll notice it's dynamically updating the label as it appears on the surface. Really cool. Let's look at elevation labels. We'll do a spot elevation label. Notice how you have the option to choose a label style as well as a marker style if you want to. Let's choose Basic X, we'll keep elevation only, and click Add. Select the surface, pick a point, similar functionality as with the slope labels. If you move it along the surface, it updates automatically, as well as if you copy the label, it'll update automatically as well. Lastly, let's look at contour labels. Let's first do a contour single to get an idea of what's going on with contour labels. These are the styles that you can choose from for major and minor contours. We'll click Add and go ahead and select our surface. What you're doing is simply clicking on a contour line to automatically add the contour label. Now let's press Escape and let's see what's really going on. Civil 3D creates something called a contour label line. This contour label line is a dynamic label that when stretched across any contour, notice how it will update automatically and show you the contours that appear across that contour label line. If you want to edit any of the properties defined by this contour label line, let's say for instance, we don't want the minor labels here, we'll go ahead and go to the Properties palette, and you can go ahead and toggle these off and on as you need to basically get whatever contour labels you need. Pretty cool. You can even copy these as well. Now if you want to do this in one full sweep, what you can choose is the Contour Multiple at Interval label type. And let's go ahead and click Add here, and then we'll go ahead and pick our surface. And what you're going to do is simply define a starting line to start from, and then the intervals along the contour that you want to be displayed. We'll go with 100, press Enter, and every 100 units, a contour label line will be placed along those contours, as you can see here. Let's say we made a mistake here, and we want to get rid of the minor contours being labeled. Here's how you do it. Select one contour label line, right-click and choose Select Similar, and then navigate to the Properties palette, and simply change your value to false, and automatically when you press Escape here, it'll update the contours. Note the contour label line does go on a layer, and you can simply set that layer to be a no plot layer. Civil 3D provides tools to analyze and calculate the volumes for volume surfaces and bounded areas within volume surfaces. To create a volume, navigate to the Analyze tab, Volumes and Materials panel, and then Volumes Dashboard. This will open up the Volumes Dashboard vista in the panorama window. Let's turn Auto Hide on for a minute. So what we want to do here is we want to get a volume calculation between this combined EG and this pad design that we have here. What you first do is you simply click on Create New Volume Surface, and Civil 3D will create a volume surface for you. And of course what you do is you define your base surface, which in this case will be combined EG, and then the comparison surface, which will be this pad here. Let's set our style to No Display, as we do not need this surface to display, we simply need it for volume calculations. Click OK. There is our volume surface. As you can see, a graph appears, letting you know how balanced your cut and fill quantities are. In this case, the pad is very high off the ground, so we have a lot of fill. Let's say though, you wanted to calculate a bounded volume based upon a specific area within your drawing. We have a pre-drawn rectangle, and what we simply need to do is select the surface, and then click on Add Bounded Volume. When you don't know what to do, look at the command line window. Select Bounding Object. We'll go ahead and click on the rectangle. If you scroll to the left here, you'll notice that there is a Volume 1.1 volume calculation, which is the bounded area. If you wanted to print out this volume calculation, you could click on the Generate Cut Fill Report, and this will open up in your default browser. If you want to place it in AutoCAD, simply click on the Insert Cut Fill Summary, and then navigate somewhere. It's going to use your current layer and properties, as well as your current text style and settings. Click on the drawing, and there's our summary as mtext.